Hi friends, today I am giving a lecture on 0 by 1 knapsack problem using branch and bound technique. So 0 by 1 knapsack problem is one of the application of branch and bound technique. The branch and bound technique mainly used for solving optimization problem. So what is optimization problem? So optimization problem may require either maximum result or minimum result. Some problems may require maximum result. Some problems may require minimum result. It depends on the given problem. Okay. Now we have to take 0 by 1 knapsack problem using branch and bound technique. So in 0 by 1 knapsack problem, we have to take a knapsack, that is the capacity of the knapsack is capital M. Now we have to place n number of objects into the knapsack. The sum of the weights of the objects is not exceeding the capacity of the knapsack. Okay. So the weights are represented by W1, W2 up to Wn. Okay. The sum of the weights of the objects is always less than or equal to the capacity of the knapsack. Our main objective is to place sum of the objects which has the maximum profit. So that objects are placed into the knapsack. The sum of the weights of the objects is always less than or equal to the capacity of the knapsack. Okay. So our objective is maximize the profit. So maximize. So sigma I is equal to 1 to n pi xi. Our main objective is maximize the profit of sum of the objects among n number of objects. So here there are n number of objects are there. We have to place only sum of the objects among n number of objects that are placed into the knapsack that has the capacity capital M. Okay. So the sum of the weights of the objects sigma I is equal to 1 to n Wi xi is always less than or equal to the capacity of the knapsack. That is sigma I is equal to 1 to n Wi xi less than or equal to m. That is sum of the weights of the objects is always less than or equal to the capacity of the knapsack. So that is one constraint. Another constraint is we have to maximize the profit. Okay, that is sigma I is equal to 1 to n pi xi. Okay, so sum of the weights of the objects that are placed into the knapsack that has the maximum profit. Next, here xi is equal to 0 or 1. So suppose xi is equal to 0 is nothing but we do not place the object into the knapsack. So xi is equal to 1 is nothing but we have to place the complete object into the knapsack. So xi is equal to 0 is nothing but we do not place the object into the knapsack. Xi is equal to 1 is nothing but we have to place the complete object into the knapsack. Okay, so these are the steps we have to follow in 0 by 1 knapsack problem. So here our main objective is maximize the profit. So we can say that 0 by 1 knapsack problem is a maximization problem because we have to obtain maximum profit. So we can say that 0 by 1 knapsack problem is a maximization problem. But branch and bound deals with a minimization problem. So we have to modify the given knapsack problem into minimization problem by putting the negative sign before the profit of each and every object. So then here minimum of z is equal to minus p1x1 minus p2x2 minus pnxn. Okay, we have to place a negative sign of each and every profit. So that is the profits are p1, p2, p3 up to pn. So then we have to put negative sign for each and before the each and every profit. Then we can get the profits minus p1, minus p2, minus p3, minus p4. So we have to get the minimized profit. So finally we again convert the negative profit into positive profit. Okay, so in this way we have to solve the 0 by 1 knapsack problem using branch and bound technique. Okay, by solving the knapsack problem in using branch and bound, we have to calculate lower bound and upper bound for each and every node. In the lower bound, we do not allow, in lower bound, we have to allow the fractions. But in the case of upper bound, we do not allow the fractions. Fractions is nothing but 1/3 of the object, or 1 by 2 of the object, or 3 by 4 of the object. So we do not completely place the object into the knapsack. Only some part of the object is placed into the knapsack. So in the case of lower bound, we have to allow the fractions, but in the case of upper bound, we do not allow the fractions. Okay, so these are the steps we are followed while solving the 0 by 1 knapsack problem in branch and bound technique. Next, we go for example problem. So this is the given example problem. Draw the portion of state space tree generated by LC branch and bound for the knapsack instant n is equal to 4, p1, p2, p3, p4 are 10, 10, 12, 8, w1, w2, w3, w4 are 2, 4, 6, 9, and m is equal to 15. So first we have to convert the given profits into negative profits by putting negative sign of each and every profit So therefore, P1, P2, P3, P4 is equal to minus 10, minus 10, minus 12, minus 18. Okay. So why we are converting these positive profits into negative profits? So here we can take the knapsack problem. In knapsack problem, so we have to obtain the maximum profit. But branch and bound deals with minimization problem. So we have to modify the given knapsack problem into minimization problem. We have to put negative sign of each and every profit given in the given problem. So P1, P2, P3, P4 is equal to minus 10, minus 10, minus 12, minus 18. Okay. So here we have to draw the state space tree. So in that state space tree, so first root node is there. So for that root node, we have to calculate C cap and U cap. So here C cap is nothing but lower bound. So C cap is equal to lower bound and U cap is equal to upper bound. Upper bound. So while calculating lower bound, we have to allow fractions. We have to allow fractions. While calculating upper bound, we do not allow fractions. We do not allow fractions. Okay. While calculating lower bound C cap, we have to allow fractions. While calculating upper bound U cap, we do not allow fractions. Okay. Fractions is nothing but, so suppose xi is equal to 0 is nothing but we do not place the object into the knapsack. Xi is equal to 1 is nothing but we have to completely place the object into the knapsack. Xi is equal to some fraction value is equal to, so it is not possible to place the complete object into the knapsack, only so a portion or a part of the object is placed into the knapsack. So that situation is called as fraction. So now we have to calculate C cap and U cap for root node. Okay. So first C cap value. So we have to calculate the lower bound. Okay. So the capacity of the knapsack is 15. Okay. First we have to place the first object into the knapsack. First object into the knapsack. Its weight is 2 and the profit is minus 10. Next, what is the remaining capacity? 15 minus 2, that is 13. Next, the second object is placed into the knapsack. Its weight is 4. Its corresponding profit is minus 10. Next, so now 2 plus 4, that is 6. 15 minus 6, the remaining capacity is 9. Now we have to place third object into the knapsack. Its weight is 6 and the corresponding profit is minus 12. So what is the remaining capacity? 15 minus 6 plus 4 plus 2, that is 6 plus 4 10, 10 plus 2 12. So 15 minus 12, that is 3. But fourth object weight is 9, but the remaining capacity is 3. Only a complete object is not placed into the knapsack. Only a part of the object is placed into the knapsack. So a fraction part can be calculated. What is the remaining capacity? That is, remaining capacity is 3. 15 minus 6 plus 4 plus 2. So 15 minus 6 plus 4 plus 2. So that is equal to 3. Okay. Remaining capacity divided by weight of that object, that is 9 into its corresponding profit minus 18. So that is minus 6. So therefore lower bound C cap is equal to, so minus 10, minus 10, minus 12, minus 6. That is minus 38. Okay. So while calculating lower bound, we have to allow fractions. So this is the fraction part. Okay. Next. So C cap is equal to minus 38. So it can be write as C cap of 1 is equal to minus 38. Next we have to calculate U cap of 1. So while calculating upper bound, we do not allow the fractions. Okay. first object is placed into the knapsack, its weight is 2 and the corresponding profit is minus 10. Next, second object is placed into the knapsack and the corresponding profit is minus 10. Next, third object is placed into the knapsack, its weight is 6 and the corresponding profit is minus 12. So total capacity of the knapsack is 15. So 15 minus 6 plus 4 plus 2, that is 12. So what is the remaining capacity? That is 3. But the fourth object is weight is 9. So we do not place the complete object into the knapsack because the remaining capacity is only 3, but the weight of the fourth object is 9. So we do not allow the fractions. We do not place the object into the knapsack. Now we have to stop that placing the object. So therefore upper bound U cap is equal to, so minus 10, minus 10, minus 12. So that is equal to minus 32. So U cap is equal to minus 32. Okay. Next, we have to place first object into the knapsack. X1 is equal to 1. We do not place the first object into the knapsack. X1 is equal to 0. Okay. So there are two possibilities are there. We have to place the first object into the knapsack. Then it can be denoted as X1 is equal to 1. So we do not place the object into the knapsack. X1 is equal to 0. So now the node number 2, the node number 3. Again we have to calculate upper bound and lower bound for node 2. We have to calculate upper bound and lower bound for node 3. For node 2, so X1 is equal to 1. So X1 is equal to 1. So here X1 is equal to 0. So X1 is equal to 1 is nothing but we have to place first object is completely into the knapsack. So therefore X1 is equal to 1. So after placing the first object into the knapsack, if any space is available, so that place is used for remaining objects into the knapsack. So for node 2, X1 is equal to 1. So here first we have to calculate the lower bound value. So we have to compulsory place the first object into the knapsack. So first object weight is 2 and the corresponding profit is minus 10 and the capacity of the knapsack is 15. So 15 minus 2, that is 13. Okay. Now this remaining place is used for the remaining objects. So the second object is placed into the knapsack. Its profit is minus 10. Now the third object is placed into the knapsack. Its corresponding profit is minus 12. Now, so what is the remaining capacity? 6 plus 4 plus 2, that is 12. Capacity of the knapsack is 15. 15 minus 12, that is remaining capacity is 3. Now there is no possibility of complete object into the knapsack. So we have to place a fraction of the fourth object into the knapsack. The fraction can be calculated by remaining capacity, that is 3, by weight of the object, that is 9, is multiplied with its corresponding profit. So therefore minus 6. So C cap of 2 is equal to minus 10, minus 10, minus 12, minus 6, that is minus 38. So C cap of 2 is equal to minus 38. Next, U cap of 2. So U cap of 2, here we do not allow the fractions. Okay. So therefore, the first object is placed into the knapsack and the corresponding profit is minus 10. The second object is placed into the knapsack and the corresponding profit is minus 10. The third object is placed into the knapsack. The corresponding profit is minus 12. So here the remaining capacity is 15 minus 6 plus 4 plus 2, that is 3. So we do not place the complete object, that is fourth object, into the knapsack because the remaining capacity is 3 but the weight of the object is 9. So we do not place the fourth object into the knapsack. So therefore U cap of 2 upper bound is equal to, so minus 10, again minus 10, minus 12. So that is equal to minus 32. So U cap of 2 is equal to minus 32. Next, for node 3 we have to calculate, so upper bound and lower bound. Here x1 is equal to 0. So we do not place the first object into the knapsack but the remaining objects are placed. Okay. We do not place the first object into the knapsack because x1 is equal to 0. So what is the second object? So second object weight is 4. Its profit is minus 10. Third object is placed into the knapsack. Its corresponding profit is minus 12. Okay. Next. Capacity of the knapsack is 15. So 15 minus 6 plus 4, that is 10. So what is the remaining capacity? 15 minus 10, that is 5. But weight of the fourth object is 9, but the remaining capacity is 5. So the fourth object is not completely placed into the knapsack. Now we have to calculate the fraction of the fourth object. So the fraction of the fourth object can be calculated by remaining capacity divided by weight of the object is multiplied with its corresponding profit. So therefore therefore C cap of 3 is equal to minus 10 minus 12 minus 10. So that is minus 32. So therefore C cap of 3 is equal to minus 32. Next, we have to calculate U cap. While calculating U cap, it does not allow fractions. So therefore, we have to consider up to this point. So second object is placed into the knapsack. Its corresponding profit is minus 10. The third object is placed into the knapsack. Its corresponding profit is minus 12. So capacity of the knapsack is 15. So we do not allow the fractions while calculating U cap. So up to this point we have to stop the placing of the objects into the knapsack. Therefore U cap of 3 is equal to minus 10 minus 12, that is minus 22. So therefore U cap of 3 is equal to minus 22. Okay. So among these two nodes, that is vertex 2, vertex 3, which node has to be expanded? Okay. So to expand, which node has to be expanded? Which node has the minimum upper bound? Which node has the minimum upper bound? So that node has to be expanded. So for node 2, the upper bound value is minus 32. For node 3, the upper bound value is minus 22. Among these two, so which is minimum? So minus 32 is minimum. So we have to expand node 2. So node 2, here we have to consider x2 is equal to 1 and x2 is equal to 0. Okay. So here the node number is 2, 3, next one 4, next one 5. So now we have to calculate, so U cap and C cap for node 4, U cap and C cap for node 5. So next for node 4. So for node 4, x2 is equal to 1. x2 is equal to 1 and also x1 is equal to 1. x1 is equal to 1 and x2 is equal to 1. So we have to compulsory place the first object and the second object. If the remaining space is available, so that space is used for placing remaining objects into the knapsack. So now we have to calculate, so lower bound U cap, lower bound C cap. So we have to compulsory place the first object. First object is placed into the knapsack 2. Its corresponding profit is -10. Second object is completely placed into the knapsack. So its weight is 4 and the corresponding profit is -10. So the capacity of the knapsack is 15. So 15 minus 4 plus 2, that is 6. 15 minus 6, 9 is there. The remaining capacity is 9 is there. So again, the third object is placed into the knapsack. So its corresponding profit is -12. Next, what is the remaining capacity? So the remaining capacity is, so 6 plus 4 plus 2, that is 12. 15 minus 12, that is 3. So we do not place the fourth object completely into the knapsack because the remaining capacity is 3, but the capacity of weight of the fourth object is 9. So fraction of the object is placed into the knapsack. The remaining capacity by weight of the object is multiplied with corresponding profit. So that is -6. So therefore C cap of 4 is equal to -10, -10, -12, -6. So that is -38. So C cap of 4 is equal to -38. Next, calculate U cap. So U cap, we do not allow the fractions. Okay. So up to this point, it is okay. First object is placed into the knapsack, corresponding profit is -10. Second object is placed into the knapsack, corresponding profit is -10. So third object is placed into the knapsack, corresponding profit is -12. We do not place the fourth object into the knapsack because the capacity is not sufficient to place the fourth object into the knapsack. So therefore U cap of 4 is equal to -10, -10, -12. So that is -32. So U cap of 4 is equal to -32. So now we have to calculate C cap and U cap for node 5.